1 second, guys. I will not start.
ये तो ऐसा हुआ कि फोन लिया ये सर
Yeah. Good morning, YouTube live students. Okay. So now let's try to understand today class multi-threading with Lambda expression and method reference. What is the meaning of multi-threading with Lambda expression and method reference, sir? Okay, it is very simple. How to create a thread? You have to learn first. What are the different ways we can create thread? You should learn. After that, you should get clarity on how to decrease the number of lines of code by using Lambda expression method reference. That's all. Okay. Along with this workshop, I want also you learn what is that? There are 3 ways of creating a custom thread, and there are 10 different ways of supplying logic to the custom thread. And there is a small confusion in the market on multi-threading. What are the different ways to create? Some people say 1 way, some people say 2 ways, some people say 3 ways, some people say 4 ways. Okay, the confusion answer, what I have to give answer to the interviewer, we should also understand on that. So this workshop is meant for giving you clarity on multi-threading interview question, what are the different ways to create custom thread, also giving you clarity on different ways of supplying the logic. In this workshop, we also learn executor framework. Okay, how to create custom thread by using executor framework, by using callable interface also we will learn. Okay, have you heard that idea? Executor framework, callable interface. Do you have that idea? Okay, all people know multi-threading first for the workshop. Java multi-threading. With Lambda expression and method reference. So this is our workshop. In this workshop, I want to learn what is a thread. Second, why a thread? Just it's a people, if you know already, it's a revision. People who don't know anything, just you can enjoy. Learn the new points. What is a thread? Why thread? Java API for creating custom. Okay. What is a custom thread? Fourth, why custom thread? And fifth, Java API for creating custom thread. Fifth, sixth, creating a custom thread by using thread class. Okay. Next, the problem in creating, only one problem there. The problem in creating custom thread by using thread class. Okay. The problem in creating custom thread by using thread class. Then 8, 2 ways of creating or 3 ways of creating custom thread. Number 1, extending from thread class. Second, implementing from runnable interface. And number 3, implementing from callable interface. Callable, it is a generic functional interface. Callable of T. Callable interface by using executor. Some people call it as executors and some people call it as executor framework. I wish to call it as executor framework. Okay. And ninth, after understanding these points, okay, then here these two topics are easy, you can easily understand, and this is little complicated, so I will separate it. And first I want here next we will understand executor framework and its API. First we'll understand the problems with runnable interface. And advantage of callable interface. First you have to understand this. Then next point you have to understand executor framework and its API. We have number 1 executor, number 2 executor service, I guess. Number 3 executors. Number 4 future. Okay, number 4 future. Now these are the 10 points first you have to learn. That means Java multi-threading. Okay, after you understand Java multi-threading, then we'll go for what? Lambda expression, method reference, apply. Then 10 different ways. Okay, applying or supplying logic, or can say implementing runnable and callable by using lambda expression and method reference. And 12th point, 10 different ways. 10 ways are some less than around 10 ways are there, exactly I didn't remember. 10 different ways. If we'll change the number after completing the code, okay? 10 different ways to supply logic to custom thread. Okay, so this is the total 12 points. This is the syllabus what we are learning. So in this, how many points you know, how many points you don't know? Just go through once. Just go through once. How many points you know already? How many points you don't know? Just check once and tell me. Okay, able to see me? Is my audio clear? Any resound? One second, guys. In YouTube live video. Okay, guys. Now let's start understanding all these points one by one. For that, first I am showing you a small diagram here. Try to observe. So I am considering again zero knowledge. Okay, I am feeling that you don't know anything. We are starting everything from the zero. Is it okay to everyone? Okay, I am feeling that you don't know anything. So that zero level I am starting and will complete all these 12 points. So before starting multi-threading, you should understand multitasking. Okay, what is multitasking? Multitasking is the process of executing multiple individual tasks at a time. Executing multiple individual tasks at a time. What is the meaning of at a time? There are three ways of executing at a time. There are three ways of executions available. Sequential flow execution, parallel flow of execution, concurrent flow of execution. There are three different ways of execution available. What the first way? Sequential flow of execution, parallel flow of execution, concurrent flow of execution. Okay. Now, what is the meaning of sequential flow of execution? Sequential flow of execution means there are two tasks are started start and end. Task 1 started and keep on going on running. Task 1 completed. Then task 2 started, keep on going on running, and task 2 is completed. This is what? Sequential flow of execution. That means one task started and after completing second task, after completing of first task, second task is started. After completion of second task, third task will be started. For example, you started watching one movie, assume. Okay, you like to watch one movie. Wonderful. So now tell me, in the middle of first movie, are you moving to second movie? No, no. You already bought a ticket for morning show. Then until that morning show 11 to 1 completed, you will be there in the cinema theater only, in that particular screen only. Once that movie completed coming out, then taking some lunch or dinner or whatever, then you are planning for second movie. So one movie after second movie, then it is called what? Sequential flow of execution. Right? Now tell me, if you wanted to run if you wanted to watch one movie after one movie, how many cinema theaters are required? One. How many screens required? One. Okay. Same example I am taking another way, which will understand easily, more easily. For example, now I am taking the classes. Okay. I am taking the classes. Okay. Morning 7 to 9, one class is there. 9 to 11, one class is there. Now 11 to 1, I am free. So I am planning for one workshop now. Right. Tell me. So first session completed, then second session. Second session completed, then third session. And then what is the flow of execution? Sequential flow. To run sequential flow of execution, how many classrooms are required? One. Okay. To execute sequential flow of execution, how many faculties required? One faculty. One room and one faculty. One room and one faculty. Remember this. This point is important. Okay. Then next, parallel flow of execution means at a time, how many tasks are executing? Two tasks. For example, if you take what do you call multi-building shopping mall, yeah, top shopping mall or multi-screen building. If you take, tell me now, in one screen, one movie running, same time in another screen, same building, another screen, another movie is running or not? Then tell me, when this movie is running here, now the interval bank come, some samosas or something for buying, you are coming outside of the theater. At the same time, in another screen also, is a interval time given? No. According to that movie, the started time, that interval time will come. Is it clear? That means one task is started, going on, end. In the middle of this task or at the same time or in the middle somewhere, second task is started and keep on going on its own path. Whatever happened to task 1 doesn't matter to task 2. Whatever happened to task 2 doesn't matter to task 1. So both are independently running tasks. Then this is called what? Parallel flow of execution. Tell me, start, end, end. Start, end, start, end. Now my question is, because this second task is started late, then it should complete later? No. If it is a small task, complete it fast. If it is a lengthy task, takes more time. There is no rule that, you started first, you only complete end. No, both are independent tasks. Now take our class example. Now I am taking class 11 to 1 in this room. In the next room, another faculty is taking the class or not? If whatever happened to my room whatever happened to my class, is there any link to another class? No. He is going in his own flow. I am going in my own flow. So both tasks are running concurrently or sequentially, parallel in a parallel. That's a parallel flow of execution. So to run the parallel flow of execution, how many rooms must require? Two rooms. How many faculties required? Two faculties. For each room, for each task, one room, one faculty required. Clear? Why I am telling this? In the next slide, you have to apply all these points. Okay? You should confirm. That's why I'm trying to link these points to the real life. Now tell me, the most danger important topic, what is that? Concurrent flow of execution. And tell me, what is the meaning of concurrent flow of execution? Concurrent flow of execution is like a sequential flow, also like a parallel flow, both. Eh? How it can be both? Yes, both. It is a concurrent flow, also sequential flow. It exhibit a sequential flow, also exhibit concurrent flow. Both it will exhibit. Okay, let's try to understand how it is exhibit both. Concurrent flow of execution means there are two tasks available. First task is started. When first task execution is paused, then only second task has a chance to start and run. Are you following? When first task is started, when first task is running, Yashwant Mishra, that's what I am doing, man. Why you are so hurry? I started the workshop on the topic only, na? That is the problem with you guys. You always break the flow of the faculty's explanation. You people don't focus on what I am explaining and you want something else. Okay? Don't be so much hurry, man. Okay. Now, okay, come back. So what is the concurrent flow of execution? One task is started, it's going on, paused. Then coming to new task is started. Then this new task is started, going on, and it is also paused. When it is paused, what happened? Now the control is shifted to task 1. Then task 1 is going on. Again it is passed. When it is passed, then again it returned to task 2. Then task 2 is again resumed, running and passed, then going to task 1. So what is the style of execution concurrent flow? Concurrent flow style of execution is start, pause, resume, end. Okay, na? Start, pause, resume, end style of execution is concurrent flow of execution. Recollect once again all 3 points. What is sequential flow of execution? Start end. What is parallel flow of execution? Multiple tasks are started and running at a time in their own path. Concurrent flow of execution is what? Multiple tasks are started, but are those multiple tasks are executed at a time? No. Okay. Are those multiple tasks are executed at a time? No. Multiple tasks are executing with pauses, with context switching. Context switching means one task to another task. Here, there are two at a times available. If you carefully observe, there are two at a times available. Parallel flow of at a time, concurrent flow of at a time. In parallel flow of at a time, both are executing independent of others. In concurrent flow of execution, at a time executing, but one task is active. When multiple tasks are active, one task only running at a time. Do you all understand? The difference between parallel and concurrent flow. In parallel flow of execution, multiple tasks are active and running. Whereas concurrent flow of execution, multiple tasks are active, but only one task is running at a time. Okay. Is this point understood? For example, sir, no sir. Now let me take an example. Concurrent flow of execution. Concurrent flow of execution, let me explain with a real life example. This is my class. Already here here, parent to child, don't go too much deep. This is students available. I'm standing here, I'm teaching the class. Okay, suddenly I got a requirement. I need to start a new batch at the same time at 11 o'clock. Is it possible? I got a requirement to start new batch at 11 o'clock. Already one batch is running at 11 o'clock. Suddenly I got a requirement of starting new batch again. Is it possible or not possible? Everyone should answer. Possible or not possible? Same time at 11 o'clock, same time at 11 o'clock, I have to start the new batch. Possible or not possible? Already one batch is there. Already I have one batch 11 o'clock. Before it's completing only, I want to start new batch. Possible or not possible? Not possible, because this currently 11 batch students will get angry on me saying that without completing syllabus, how can you start new batch or not? But possible. I have the plan. I'm a Java developer. What is the development plan? I will take one room next to this room. Okay? Another room I'll take here. Then the new students, I am asking them to sit in this room. Okay, tell me, how many batches are active now? 2 batches are active. Okay. How many batches are running? One batch only running. Currently, I am in this room, na? I am talking here. This batch is running, no. Now, what am I doing? For 15 minutes, I am explaining here and asking the students to copy the notes from the screen, which I displayed on the screen. Then tell me, these students are taking 15 minutes for writing the notes. Then that 15 minutes, my time is waste here, na? Then here there is a door. Okay, and this room also has a door here. What am I doing now? I am going from here to here. Then I came here. Okay, then now I started saying, hello, good morning everyone. This is Krishna. I'm here for taking your core Java new batch, full stack Java batch. Then I am making these students active and running for how much time? Completely? No, for 15 minutes. Okay. After 15 minutes execution completed, what am I doing? I am asking these students to write notes, and again I'm coming back to previous class. Then here I'm teaching for 15 minutes, again asking them to write notes, coming back to this room. Now tell me, like this, I am moving from that room to this room to that room until both room tasks are completed. 1 o'clock class completed, 1 o'clock class completed. And tell me, how many classes I have handled? 2 classes. At a time or? At a time or not? Yes. But running at a time or? No. Both tasks are active, but running only one task. Another task is paused. When first task is running, second task passed. When second task running, first task passed. When first task running, second task passed. So the execution flow is going only one side. Other task is passed. Parallel flow is what? Both are running. Ting, 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 in their own path going. Sequential means what? Only one. After one completed, second coming. After second completed, third coming. After third completed, fourth coming. Mahesh Babu running. Sequential flow. Okay. Now all people understand a sequential flow, concurrent flow, parallel flow of execution. If all people comfortable, then I will ask a question. Ready? Synchronize. Yeah, these are all different topics. Don't mix up. Be at basics. Okay. So now final conclusion. What is sequential flow of execution? Executing multiple tasks one after other is called what? Sequential flow of execution. Start end flow of execution is sequential flow of execution. What is parallel flow of execution? Starting and running multiple tasks at a time. Two tasks are active, two tasks are running in their own path of flow of execution is called what? Parallel flow. Start to start, end to end. Next, concurrent flow of execution means two tasks are running, two tasks are started, and but not both not running at a time, both not running at a time. One task running, other task is paused. When other task is currently running task is passed, then second task is active running. When a second task is passed, then first task is active and running. That means only one task is running at a time. Other tasks are passed. So start, pause, resume, end style of execution. Start, pause, resume, end style of execution is called what? Concurrent flow of execution. Now my next question. For running multiple tasks sequentially, how many rooms required? One room. How many faculties required? One faculty. Next. For running parallel flow of execution, how many rooms required? Separate room for each task. How many faculties required? Separate faculty for each task. Next. For running concurrent flow of execution, how many rooms required? How many rooms required? Separate room. For each task, one separate room. But to run those tasks, how many faculties required? One faculty. Now finally tell me, if one faculty handling multiple tasks, if multiple tasks are handling by one person means that is parallel flow na or concurrent flow na? Excellent, marvelous. Multiple task, each task is handling by separate person. Then what is this? Parallel flow. Super. One person, one task, one room. What is that? Sequential flow. Okay, na? Marvelous. Come back. Come back to the multitasking. Show your talent here. What is multitasking? Multitasking is the process of executing multiple tasks at a time. What is that at a time? Parallel or concurrent? Tell me. Operating system executing multiple tasks at a time. Is it parallel or concurrent? Definitely not sequential. No? Definitely not sequential. It is a parallel. Parallel? Everyone. Executing multiple tasks at a time is called multitasking. That at a time is parallel at a time or concurrent at a time. All people are putting your leg in a dal. పప్పులో కాలేశారా రే ఇక్కడ ఏం చెప్పారు వాట్ డిడ్ యూ సే రే one faculty handling multiple tasks is what flow? Concurrent you told na? Mari. Who is the faculty? Operating system. Who is the room? Process 1, process 2, process 3. Who is the task? Edit plus software, VLC media player software, browser software. Then what is this? What is this? Parallel flow na concurrent flow na? Concurrent na? All we people are feeling, yo, my computer is running parallel. Really parallel? No, concurrent. And no, sir. When I am typing my code in Edit Plus, I can listen music here. I can download some new content from the browser or new software from browser. All three are going at a time now, sir. How can I say concurrent? Concurrent means when it is running, these two tasks are passed. When it is running, remaining two tasks are passed. When it is running, previous two tasks are passed. Right? Then how is it possible you say this is a concurrent flow? This is a concurrent flow. But all three tasks are at a time running, sir. I can see, I can experience now, sir. That is parallel only. I cannot believe concurrent. Excellent. There is a small problem here. Computer execution is slow as you are slow or faster? Fast. Here what happened? The computer processor, who will execute all these process? By processor, your processor. Your processor running this, shifting here, running this, shifting here, running this. Again coming, again going, again coming, again going, again going, again going. Tell me, this context switching means one process to another process changing is called what? Context switching. The context switching from one task to another task is very fast, very fast. Your eye cannot catch. It is very fast, your eye cannot catch. Very fast, your eye cannot catch. Because it is moving from there to here, here to there to here to there. That's why you don't feel it is running fast. You don't feel it is a concurrent flow. You feel it is a parallel flow. You know, there is something called task manager. Alt Shift Del if you press, you will get a task manager. In a task manager, whenever a system running slow, whenever your system running slow, what are you doing? You are going to task manager, choosing the processes which is taking more memory space, more CPU time. You are selecting, right click and killing. When you kill this, then your task is running fast. Parallel flow, what is the problem? If it is a parallel flow, your task is running with your memory space, this process running with this memory space. Why your task is taking more time to execute? Why the control is not coming to your task? Why your task is fast? Because this task hold the control. Understood? This task hold the control, not releasing the control to go to the another task. Then you feel system is got hanged. You are saying, na, my system hanged, mama. I should restart. Why you are restarting that? Why it is hanged? Because there are 4 tasks running in your system. This task taking more time to execute. It is not releasing the control. Hence, it is not coming out to your task to execute. That's why your edit plus software is passed, or your YouTube video is passed, or your another task is passed. Then what are you doing? 2 options you have. Either restart the system or kill this process. When you kill this process, then no one is holding. Then again, freely moving control from there to here, here to there. Okay, maybe these modern computers, you are not facing this difficulty, but when we are working on P4 Pentium 4 P4 and old generations Intel processors and all, if you were, we face so many problems like this. And moreover, in Edit Plus, while I'm typing the code, suddenly my characters are missing there. I am typing, but characters are not coming. After 1 or 2 seconds, then all characters are flown. What happened meanwhile? Another task hold the control. It is not releasing the control. The moment when it release the control, then process is coming back to my Edit Plus. All the characters are displaying now. So that is called concurrent flow. I have experienced computer flow is a concurrent flow. I don't know about you. So, and moreover, I am clearly saying that one operating system how it can execute multiple tasks at a time. One person can perform only one task at a time. If he is moving from one task to another task, either complete it and go or pause it and go. Understood? You have one mobile. In one mobile, can you watch two videos? You have one mobile. In that one mobile, can you watch two videos? No. What are you doing? You are watching sometime here and then shifting to this video. Watching here, shifting to this video, and again watching, shifting to this video, again watching, shifting. So what else? One mobile is concurrent flow. So finally, all the people are agreed operating system execution flow is concurrent flow, not parallel flow. Okay, in our computer we have single core operating system, multi-core operating system. Some names coming nowadays. Single core, multi-core, single core processor, dual core processor, multi-core processor. Amol, not fully satisfied. What not fully satisfied, man? What is the meaning of single core? Single core means only one processor handling all the process. Okay, multi-core or dual core means two cores are there. It is handling one process, it is handling another process. This is what my understanding. If anything is mistake, you can tell me, because some of you have already learned what you call operating system. So you are good at operating system. I studied operating system in childhood. If I do any mistake in explanation, you can tell. And tell me, this is one core, this is second core, core 1, core 2. So core 1 handling this process, core 2 is handling second process. That means now these two tasks are now running parallel. Are you following? A single core means concurrent. Multi-core means parallel, parallel, parallel. Understood? Now, one core can handle only one process. Suppose if multiple processes, if I start, what happened? Core 1 already handling one process. Then when I start another process, another task, one more task if I start, then this core only handling the second process. Okay, two tasks already busy by core 1, core 2. Now one more process I started. Then what happened? One more task is started here. One more task distributed. Now the number of tasks you are starting in your computer distributed to both the cores. Tell me, this core to this core execution is what? Parallel. Okay, na? Within the core, one process to another process is what? Concurrent. Understood? Understood? Operating system level is concurrent, buddy. Confirm. But to divide the task of the concurrent, they have introduced a concept called what? Core. Initially, every processor is a single core operating system, single core process. Later, they introduced dual core. Two cores are there. Now, these two cores, what happened? Now, two processes in two cores will be parallel, and within the one core, multiple processes are again what? Concurrent. This is how slowly your computer performance is started increasing. These core concepts they have introduced. And next, what is the multi-core means? More than two cores available, multiple parallel programming you are getting. So this is what my basic understanding on this multitasking. I'm not going to more deeper in operating system because we are not teaching here OS. Okay. If any corrections are there, you can happily let me know. We will correct it. Up to now, we are considering as a single core operating system. Okay. It's a single core processor, single core operating system only considering. And now finally tell me, whenever you have started any task, to run this task, operating system will assign one process. As many tasks you want to run, those many processes are started. All these processes are executed by your processor. Your processor, na Intel processor. Processor is responsible for executing all these tasks. Processor will shift the control from one process to another process and again coming, executing one process, again coming. So one process can handle multiple tasks only concurrently, but our eye cannot catch the speed, moving the cursor, moving the control, switching the control from one process to another process. Hence we were feeling that, assuming that it is a parallel processing, but not parallel processing. It is only concurrent flow. Okay, now fine. Up to now, all people understand. So tell me, what is multitasking? Multitasking is the process of executing multiple individual tasks at a time concurrently. My statement is clear now? At a time concurrently. Clearer? Concurrently means context switching there from one process to another process. Okay. Now tell me. Whenever one task is going on, in that one task, there is a chance that multiple subtasks will be there or not. This is task 1. In that, we have multiple subtasks. Task 1.1, 1.2, 1.3. For example, the best example everybody is saying, same thing I am taking for your understanding also, MS Word. In MS Word, while you are typing the sentences, if any spelling mistakes or grammar mistakes, background the spell checking is going, grammar checking is going or not? Task 1 is typing, task 2 is what? Spell checking. Both are happening under one process called what? MS Word typing. So tell me, every main task, this is a main task 1, this is a main task 2, and this is main task 3. Every main task internally contains what? Subtasks, 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 subtasks. Now tell me, if this subtask all I typed completed, then spelling mistakes and grammar mistakes are checking, then again I have to go back and correct that mistake. Time taking process now. That's why what is doing? Immediately, once you type, immediately checking the spelling. Once you type, immediately checking the grammar mistake and showing. We are correcting there itself and then move to the next one. So that means, now tell me, inside one main task, again I need multiple subtasks execute concurrently now. When typing completed, shift to spell checking. Spell checking completed, shift to typing. Typing completed, shift to spell checking. So tell me, how can we execute, how can we handle multiple tasks inside one main task concurrently? That is where we are coming to a concept called what? Thread. Okay, tell me, this main task is handled by a special program called what? Process. And these subtasks are handled by subtask 1, subtask 2, subtask 3 are handled by whom now? Thread concept. The thread is responsible handling subtasks. So tell me, one process contains how many threads? Multiple. One operating system contains what? Multiple processes. That means at the process will be coming at what level? Operating system level. Threads are coming at what level? Process level. So tell me, there are two types of multitaskings available. Number one, process-based multitasking. Number one, process-based multitasking. Number two, thread-based multitasking. This is process-based multitasking. This is thread-based multitasking. Everyone following up? Process-based multitasking is the process of executing multiple main tasks concurrently by using process. Thread-based multitasking means executing multiple subtasks in a main task. Executing multiple subtasks in a main task concurrently is called concurrently by using thread concept is called thread-based multitasking. Okay, now? Now tell me, process-based multitasking is heavyweight, thread-based multitasking is heavyweight. Heavyweight and kg, sir. This is a 10 kg, this is 5 kg. Here weight means not kgs, weight means taking more time to execute, consuming more resources to execute. More resources means memory. If more resources are consuming, more time is consuming, then we call it as what? Heavy weight. Less resources are consuming, less memory is consuming, then we call it as what? Lightweight. Now listen, Process-based multitasking is a shortcut. People are calling it as what? Multitasking. Thread-based multitasking, people are calling it as multi-threading. Are you following? So, process-based multitasking, thread-based multitasking, lengthy words, lengthy names. That's why to shorten it, to minimize it, people are calling it as multitasking and multi-threading. So now tell me, people are giving a question, asking question. What is the difference between multitasking and multi-threading? Can you summarize now? Difference between multitasking and multi-threading. Multi-threading. So tell me, first point is what is multitasking? Executing multiple individual main tasks is called what? Multitasking. What is multi-threading? Executing multiple individual subtasks of one main task. This is only main task. This is what? Subtask of one main task is called what? Multi-threading. Both are executing concurrently. Second one, multi-threading will come at a OS level. Multitasking will come at what? Sorry, multi-threading is come at what? Process level. Third point, multitasking will be handled by processor with the concept called what? Process. Repeating again, multitasking is handled by processor with a special program called what? Process. For each one main task, one process is created to execute. Multi-threading is handled by a special program called thread scheduler. What the program name? Thread scheduler. Thread scheduler is responsible for handling the threads with the help of a special program called what? Thread. A special program called thread. Repeat once again all the 3 points. First one, what is multitasking? Multitasking is the process of executing multiple independent main tasks concurrently is called multitasking. What is multi-threading? Multi-threading is the process of executing multiple individual subtasks of one main task at a time concurrently is called multi-threading. Second, multitasking will come at OS level. Multi-threading will come at process level. Process level. Next, multitasking is handled by processor with the help of process. Multi-threading will be handled by thread scheduler with the help of thread. Now, fourth very important point. Multitasking is heavyweight. Multi-threading is lightweight. What the meaning of heavyweight, lightweight? Tell me, this is our tasks. Now, inside one process, multiple tasks available. Shifting from one process to another process take more time. Shifting from one thread to another thread take more time. Which one take more time? One process to another process will take more time. Why? Because it is available in one memory space, this is available in another memory space. Both are individual houses. So tell me, going from one house to another house, you have to go outside of the door and then move some distance and then go inside this house. Now tell me, threads are available in another house or same house? Same house. Why? They are the part of the one house. Moving from one room to another room, one room to another room is easier. Na? Takes less time. Na? So this is heavyweight. Multitasking is heavyweight and multi-threading is what? Lightweight. Okay. Everybody got clarity all 4 points? So comfortable? Now finally we have completed first section called 3 points we completed. What is the first point? What is multitasking? Then what are the different ways of execution of multiple tasks? What are the different ways of execution of multiple tasks? Then next one is what? What is multitasking? Is it a concurrent flow or parallel flow or concurrent flow? Then next we discussed about multi-threading. Multi-threading means executing a multiple subtask as part of one main task. Okay. Now there are two types of multitasking: process-based multitasking and thread-based multitasking. With this, we completed the basic foundation. Now we are coming to our main chapter. What is our main chapter? Multi-threading. Now come. Now I'm coming. Multi-threading in Java is okay. Tell me, executing multiple tasks in Java, is it multitasking or multi-threading? Executing multiple tasks at a time in Java, is it a multi-threading or multitasking? Multi-threading. Why multi-threading? Why multi-threading? You are running multiple tasks inside JVM. Na? JVM is responsible for executing multiple tasks. What is JVM? JVM is a process. Super. JVM is a process, not processor. Akash. Processor is not different, process is different. Okay. JVM is a process. Hence, at process level, it is a multi-thread. Okay. Try to understand now. I am writing one program now. So we entered into multi-threading environment. I am writing one class. Inside class, I have defined one method M1, M2, M3 and main method. Inside main method, I am calling M1, M2, M3 methods. Now, all these three methods are executed sequentially or concurrently. All those three methods are executed. Anil, simultaneously meaning concurrent. Simultaneously means you pass, I will execute. Again you pass, I will execute back. Simultaneously, concurrently, both meaning is same. Please re-verify once again. As per my knowledge, both are same. This is my example class. Inside this example class, I have created M1 method, M2 method, M3 method. Three methods I created. Now, inside test class, I am calling the three methods, M1, M2, M3 methods. Okay. Now tell me, this flow of execution is sequential flow, not concurrent flow. Come on. This is our JVM. When you run this test class, JVM is started. And everybody know that JVM software internally divided into, JVM memory internally divided into five runtime data areas. I am considering three runtime data areas. What is that? Method area, heap area, and then Java stacks area. Inside Java stacks area, by default, there is a one thread created. Sir, what is thread and all? I will tell you. Okay, one thread created. Okay, the name of the thread is what? Main. Just accept now. I will explain everything. Now tell me. Now main method area, heap area, Java stacks area with main thread ready. Then now first step what happened? JVM searching for this test class not available. Then loading the test class. Test class is loaded. Inside test class what is there? Main method. Then main method execution started in main thread. Okay, main thread. Now inside main method you have SOPL and printed. Next example.m1. Then what the meaning of it? You are asking the JVM to execute M1 of example class. M1 of example class available in the main thread? No. Oh, sorry, it is available side now, sir. Hey, side should not go in the JVM. In the JVM, you have to search in method area. Available or not available? Not available. Then first step is what? Load the class. Load the class into JVM. What is the class? Example class. With what methods? M1, M2, M3. Then now from the main method, M1 method loaded and executed here. After M1 method execution completed, control go to main method. In the main method, next line we have written M2 method. M2 method loaded here, executed and destroyed. Control is going back to main method. In a main method, you have to call M3 method. Then M3 method executed and then destroyed. Control is going back to main method. Main method destroyed, thread destroyed, JVM destroyed. Am I going fast? Understood? Now tell me, if I call multiple methods inside main method, all these methods are executed sequentially. All these methods are executed sequentially. Tell me, if all these methods are executed sequentially, there is a problem. What is the problem? Suppose this M2 method is taking lot of time to execute. It is taking lot of time to execute, or its execution is paused here due to some reason. Okay, due to some reason it got paused. For example, it's running. It's got a phone call, went outside for 15 minutes. Then 15 minutes this M2 operation is paused or not? Then what about M3 method? M3 method has to wait now. How long M3 method has to wait? Until the friend, that M2 method phone call completed 15 minutes, come back. That means 15 minutes time wasted to M3 method or not? Let us practically experience. To experience this, I am writing scanner class, scanner object created, asking the name to enter and reading the name. And then observe the flow of execution, control F11. Main start. Observe test main start. M1 is executed. M1 is execution start. M1 execution completed. After that, control is going to M2 sequential flow. Now M2 execution start. Then what is that? Enter name. I am not entering. Okay, I got a phone call. I went outside. Okay, now I got phone call. I went outside. Okay, happily I'm waiting for 5 minutes to 10 minutes outside, and then come back, enter my name. Array. Now M3 got a chance to execute. Tell me, is it a concurrent flow or sequential flow? Na? Sequential flow. Sequential flow of execution. Sequential flow of execution. What is the problem? Time taking, time wasting, not time taking, time wasting. If one of the task execution is passed, other tasks also has to pass. Let me give you one practical example. Okay, all the people know bank. In the bank, there is a counters. Okay, there is a counter. This is a deposit counter, and this counter, all people are already form a line. Now I taken leave for 15 minutes to deposit some money, then went to the bank. Already in the bank, there are so many people are available here. Now I'm the last person, 50th person. Hey, tell me, is it possible for me to complete all the 50? Is it possible to complete my deposit operation within half an hour? Not possible. Now, then I got frustrated because my manager will scold me. Na? I taken only 15 minutes time to complete deposit and go back to office. Then I got frustrated and shouting like anything. Then manager, somewhere available in the corner, he found that what is happening. Then I'm shouting manager also. Being a manager, you should open one more counter. These many people are arranging in a single counter. Then the manager look at the corner. All the employees are there doing some chit chat bathing. Then he shouted at one more person come here. Counter is open. When counter is open, what happened? All these people are running to this side, na? And this counter become empty. Okay, then tell me, both people at a time, two deposits are completing. Finally, transaction completed fast. Okay, na? So tell me, concurrent flow of execution, wasting time or saving time? saving the time. How it is saving the time? The time wasting will be saved. Okay, listen, I have another question. In olden days, very olden days, there is something called cinema theater tickets are issued from the counter. There is no book my show and all. So now this is a counter. The person is there inside the counter. This line is gents line and this line is, this side line will be the ladies line. Okay, this side is ladies line. Then tell me, here one person is there. This one person is keep on giving tickets to gents side. Then ladies will shout na. He's keep on giving the tickets to ladies side. Then gents will shout na. Then what he's doing? He is giving 5 tickets to the gents side, 2 tickets to the ladies side. Again shifting 5 tickets to the gents side, 2 tickets to the ladies side. Then you may question me, sir, why partiality, sir? Why ladies 2 tickets only, sir? You are, giving less priority ladies, sir. Not like that. Namaskaram, Prabhu. Because there are generally more gents will be here, less number of ladies available for ticket counter. That's why more this side, less this side. Tell me, the one person is shifting sometimes here, pausing, coming here, pausing, going back, resuming, pause, coming back, resume, pause. Tell me, this style of execution is what would be concurrent flow. Now tell me, if you want to achieve concurrent flow, I should have one path of execution or 2 paths of execution. Everyone, there will be some recommendation candidates will be there. The recommendation candidates directly go into the ticket counter and taking tickets and going na. Totally tell me here how many paths of execution available? 3 paths. Gents path, ladies path, VIP candidates path, recommendation. Then the same person is turning around all the 3 people and distributing tickets. So tell me, if you want concurrent flow, how many paths of execution required? Multiple paths. But now tell me, currently in my program, how many paths of execution? Only one path. So finally tell me, what is a thread? Bujji, conclusion. What is a thread? A thread is an independent sequential flow of execution path. A thread is an independent sequential flow of execution path. If I use only one thread in my program, all methods are executed sequentially one after one. If any one of the method execution is passed, remaining methods execution also automatically passed. Then tell me, what is the solution to this problem? If I use one thread, one sequential flow of execution. But what I want whenever this method execution is passed, immediately I want to shift to another. For that, I need one more thread of execution. This is one thread of execution. I need one more thread 2 of execution. I need one more thread 3 of execution. Everybody following up? One more thread 3 of execution. Now, as many threads you want to execute, as many tasks you want to execute, those many separate paths you have to create. Now tell me, by default JVM providing how many tasks, how many thread of execution? One, which is main thread. But now I want multiple other threads. Then in that case, I have to create my own thread 1, my own thread 2, my own thread 3. Then M1 method I load here, M2 method I load here, M3 method I will load here. M1 running. It's paused. Then JVM shifting to second method because another path is there. Now M2 method running and pass. Then it is shifting to another method. Running and pass. Then shifting to first thread. Tell me anywhere time is wasting? No. Time is saved or not? Tell me, what is multi-threading? Someone asked, sir, tell me the definition of multi-threading proper. Yashwant, what is multi-threading? Multi-threading is the process of creating multiple custom threads for what? For executing multiple tasks What type of multiple tasks? For executing multiple independent tasks at a time concurrently. Why? To complete their execution in less time. How? By using CPU ideal time effectively. One more big definition. Come back. What is a multi-threading? Multi-threading is the process of creating multiple custom threads for executing multiple tasks, at a time concurrently to complete their execution in less time by using CPU ideal time and a free time. By using CPU ideal time effectively, is called multi-threading. What is the advantage of multi-threading? I can run multiple tasks in less time. I can use CPU resources effectively. This is the advantage. So what is multi-threading? And only one point, creating multiple custom threads. Why multi-threading? For executing multiple tasks at a time concurrently. How execute multiple tasks at a time? By using CPU ideal time effectively. Then what are the advantages of multi-threading? We can run multiple tasks at a time concurrently so that the CPU ideal time we can use effectively to run other tasks. It means when one task execution is passed, we are not wasting time there. Immediately we are moving to another task and executing, coming back. So that's the ideal time we are using effectively. That is called multi-threading. Understood a multi-threading? Now, what is our task now? If I call M1, M2 method in main thread, my program execution is taking more time. Then what are you learning in this chapter? Number one, how to create our own custom thread. Number two, how to load our logic and execute our logic in this custom thread. Tell me everybody, multi-threading, multi-threading and is simple, only 2 points, that's all. First point is what? How to create custom thread. Second point is what? How to execute my logic in this custom thread. If you know these 2 points, Katham, multi-threading chapter over. How simple multi-threading chapter. This 1 hour of the 1.5 hour of the basics will make you multi-threading chapter easy. In colleges, you will not learn this much heavily, deeply, structurally. The awareness, subject awareness, you will not get in your colleges or in the textbooks. That's why people are feeling multi-threading chapter very tough, very tough, very tough. Hope you all comfortable. What you have to do? Mindset created. Everybody, mindset created. Look at here the notes. Multitasking. What is multitasking? Types of multitasking. Difference between multitasking and multi-threading. Different approaches to run multitasking sequentially, parallelly, and concurrent. At OS level or at programming level, we will have concurrent flow of execution, but not parallel flow of execution. Does Java provide multitasking, multi-threading because it is run by a process called JVM. Detailed notes is there. Next, what is a thread? A thread is an independent sequential flow of execution path. Java is a multi-threaded programming. Java is a multi-threaded programming language. It means inside JVM we can have multiple threads. What is multi-threading? Multi-threading and why multi-threading? Multi-threading is the process of creating multiple threads for running multiple independent tasks concurrently to complete their execution less time by using CPU idle time effectively is called multi-threading. Advantages of multi-threading. What is the advantage? Number one, we can run multiple independent tasks concurrently at a time. We can complete project execution fast. We can use CPU idle time effectively. We can use CPU resources effectively. Need of multi-threading in this chapter. In this chapter, we don't learn how to develop logic. We will learn how to run our logic concurrently. Yes or no? We already learn how to develop logic, how to develop business logic, how to develop persistence logic, how to develop presentation logic. Only 3 logics available in Java. business logic, presentation logic, persistence logic. How to develop these three logics already we learned. But now what are you learning this chapter? What the need of this chapter multi-threading? In this chapter we don't learn how to develop logic. We will learn how to run logic concurrently. Okay, in previous chapter we run task method sequentially by using single thread main thread. The sequential flow of execution takes more time because when one task execution is passed, we cannot use the passed time to run other task. In this chapter we will learn what creating our own new threads, running task or methods concurrently in those new threads. Okay, nobody? Now, what is a custom? Custom means what? User defined. A thread newly created by a programmer is called custom thread. Then how can we create a custom thread? What the problem of this thread approach? These points we'll discuss in tomorrow class. Hope you all understood. What is a thread and what is multi-threading? Why thread and why multi-threading? Okay. So all people are got clarity. Your 1.5 hour time is uh, utilized effectively. 1.5 time spending with me is worth Varma worth. All your doubts are cleared. So are you interested to join tomorrow at 11:30 to continue the session? Okay. Then Naresh IT and we are giving good knowledge, na? Then what the benefit you are giving me back? Okay, by conducting these free classes, what the benefit Naresh IT getting? What the benefit I am getting? Satisfaction. Helping the more people to learn Java and getting clarified their doubts. Okay, no? Okay, simultaneously means concurrent. Huh? Okay, no problem. Java trainer, please don't become Java trainer above. Become Java developer. Developer life has more. Developer life will be what do you call more life, more family time you can spend, more money you can get. If you are passionate about teaching, then only come to teaching field. Otherwise, don't come. You will not have personal time, family time. Your entire time has to spend for the students. Okay. So developer, first priority to developer life. So more salary, more life, lot of things will be. Can we change from software testing to software developer? Yes, you can change. Okay. Have some doubts on map. Yeah, ask Praveen. What's the doubt? Iterator of new int of 0 comma 1 comma t dot t of this is map method or reduce method? First, you understand iterate method. Okay. Praveen, first what iterator method is doing, you understand. Don't directly call map. There you call for each method so that it will display the values. Then call for each method. Call map method so that you will get clarity. Yeah, Ram, correct. Yeah, map method is for just returning the value. Okay, you giving one element, in that element place, new thing is coming. New element e of 0 always returning e of 0 in place of every element. But first you should understand what iterate method is doing now. Map method what is doing? This is a map method. Map whatever element you are giving. For example, you give in place of e, it is always returning what? E of 0. Whatever there in e of 0, same thing is written. It is a transferring. But before you call what? Iterate method. What that iterate method is doing? That you change. Okay, na? Okay. Yeah, notes in the same Google Classroom I'll upload. All people are part of Google Classroom now in the previous workshop. In the same Google Classroom, I'll upload today notes also. Yeah, Stream API notes actually I forgot, sorry. Now I'll upload. Afternoon. In the afternoon, I'll upload. Now did you understand? T of 0 means array of 0. T is their array. You are getting array. So in that array, every element is written with 0. Yeah, I'll upload. Thank you everyone. See you all tomorrow at 11:30. Yeah, Ramu, ask. Tomorrow time is 11:30. Yeah, DSA you have to learn, OS not required. Unix you have to learn. Linux OS you can learn. Linux scripting you have to learn. And DSA data structures and algorithms. Okay. Okay guys, bye. See you tomorrow. Don't miss tomorrow class.